So far, in this specialization, data has always looked pretty beautiful. We sometimes did a little bit of feature engineering, like taking raw text and turning it into bag of words, countable words, or TF-IDF. Sometimes we created more advanced features like polynomials, sines and cosines, and so on. We did feature transformations, feature engineering, but we always observe all of our data. So for every feature, we always observe every possible value for every data point. Now that is rarely true in the real world. Real world data tends to be pretty messy and often is fraught with missing data and unobserved values. And this is a significant issue we should always be on the lookout for. In today's module, we're going to talk about some of the basic concepts and ideas of what you can do to try to address missing data in a learning problem. Approaches to dealing with missing data are better understood in the context of a particular learning algorithm. So for this module, we're going to pick decision trees as a way to kind of better see the impact of missing data and some of the key approaches to dealing with it. Again, we're going to be dealing with loan data. So as input xi is kind of that, the term of the loan, your credit history, and so on. I'm going to push it through this crazy decision tree, trying to make a decision whether your loan is safe or your loan is risky, which is going to be the output y hat I that we're trying to decide here. As we discussed thus far, we've assumed that all of the data was fully observed. So nothing was missing. So for every row of the data, for every feature we observed, for example, if the credit was excellent, fair or poor, if the term of the loan was 3 years or 5 years, if the income was high or low. And we observed the output, of course, safe or risky. Now, in reality, we have missing data. So missing data, for example, in this highlighted row might say, I know that for this particular loan application, the credit was poor, the income was high, it turned out to be a risky loan, but nobody entered in there whether the loan was a 3-year loan or a 5-year loan. And that might be true for multiple data points. And the question is, what can we do about this? What impact it has on our learning algorithm? What happens? Well, missing data can impact our learning algorithms both in the training phase, because I don't know how to train a model when you have these question marks, I don't know what value those have, and it can have an impact when prediction time. Let's say I build a great decision tree, I put it out in the wild, I'm at the bank, somebody figures an application in there, but we don't know a particular entry. What predictions do we make? So let's be more specific. Let's say that we have this tree that I learned from data, and I have a particular input where the credit was poor, the term was 5 years, but the income was a question mark. I don't know the income of this person. So I tried to go down the decision tree. I hit credit first. Credit was poor. I hit income. That was a question mark. I don't know, it was unknown. What do we do next? So we're at a learning problem where you have some training data, we extract some features, we fed to a machine learning model, which then use a quality metric to learn a decision tree T of X. But we're in a setting where some of the data might be missing at training time, and some of the data might be missing at prediction time. And what do? And what we're going to do is modify the machine learning model a little bit, the decision tree model a little bit, to be able to deal with this kind of missing data. Let's see how.